All right, it's your old pal, Mr. Cook, and we are working on the Unit 5 test review. And we are on the back page now looking at the series, problems. So the series, wherever it says series, like that's a dead giveaway that you're working with these finite sums or these infinite sums, okay? So notice that the finite sums, there's one for arithmetic. It's because you can't find the infinite sum for arithmetic because it'll just be an infinite or negative infinity. But you can for a geometric summation or a geometric series. And that's given some constraints. We'll talk about those when we get to the infinite geometric series. All right, so, these are the formulas that you use whenever you see that keyword of series in there, okay, or sum. So just know that those words are a dead giveaway that this is what you're looking at. Or even the convergence divergence ones are technically using these too because they're part of the series as well. Anyways, so number 10. Evaluate the arithmetic series. It even tells us what it is. Arithmetic sum, so that's this one. So let's write down the formula for that. All right, let's make sure we have a space there. There we go, you can see that, yeah. So we have the sum is equal to n over 2 times a1 plus an. So we need to know what each one of those parts represent. N is the number of terms, a1 is the first term, an is the very last term in the series. So you can get each of these really easily. The n value is just the number that's on top of the sigma. So that's 40 is equal to n. So we're going to plug that in. 40. There we go. A1 is the very first term in the sequence. So to find that, plug in the bottom number, 1. So if I plug in 1 to this equation, I get 7 times 1 minus 16. And then 7 minus 16 is going to give you, oops, why do I have that parenthesis there? 7 minus 16 is negative 9. So negative 9 is this first term here. So I'll place that in there, negative 9. And then the last term is the number that we find, at the top here, that n value. We just plug that into the equation. So A40, the last term, is equal to 7 times 40 minus 16. So that's 280 minus 16, so that'd be 264. Yeah, 264. All right, so that's the number that goes in for AN, 264. And then we just simply use our calculators. So now the rest of it, yeah, let's put it there. There we go. All right, so 40 over 2 times parentheses, negative 9 plus 264 equals 5,100 on the dot. So there's our answer, 5,100. All right, let's do the next one. Find the sum of the first 54 terms, so that's n, of the sequence. So negative 2, 3, 8, 13, 18. So we keep adding 5, so it's arithmetic. And we even have the first term, a1 equals negative 2. And if it's an arithmetic sequence or series, then that means that we're going to be using this formula again. So let me write that in there. S equals n over 2 times a1 plus an. Let's find each of those values. Well, I already know n, that's 54, so that goes there. I know a1, that's negative 2. Now I got to find the very last term in the sequence. So I have two options. I can find, so adding 5, the 54th term, I have the first 5, that'll take forever. Or I can just really quickly, find the explicit formula and then plug in 54. That's like the easiest way to do it. So let's find the explicit rule real quick. AN is equal to A1 plus D times n minus 1. So I already know the first term, that's negative 2. I know the common difference, that's 5. So all I need to do to find the 54th term is plug in 54. So A54 equals negative 2 plus 5 times 54 minus 1. Then, use your calculator, obviously, for that. So let's see, let's type it in. Negative 2 plus 5 times parentheses, 54 minus 1 is 53. So that's going to be equal to 263, and that's my last term. So that's the number that goes over here, 263. Now let's find the sum. So let's plug this into our calculator now. 54 divided by 2 times parentheses, negative 2 plus 263, and you get your answer, which is 7,047 for the summation. And that is it for that one. So let's get through the rest of them. I think we might have enough time to just finish off the worksheet. So now we have evaluate each geometric series. So geometric and the finite sum. So that's this equation that we're going to use. Let's write it down. A1 times big parentheses and then a fraction 1 minus r to the n over 1 minus r. All right, so we need to know the common ratio. And if you look at this formula, this gives you all the information that you need aside from n. Because since you know it's geometric, this is the geometric explicit rule. So the number that's in the parentheses, that's the r value. So we just replace r with -3 in each case. There we go, -3 and -3. N is still the same number. It's the number that's on top of the sigma, so 10. So n is 10. And A1 is the first term. You could plug in 1 if you wanted to, or look at the formula again. A1 is the number that's multiplying out front, so it's 4. So let's put a 4 there. This one's kind of tricky to plug into your calculator, okay? So one thing that you can do to make it easy on yourself is do each part individually instead of just plugging everything in at once. Like, let's figure out what -3 to the 10th is on our calculator. -3 to the 10th power. Wait, I better put parentheses around that. So parentheses -3 to the 10th power. All right, so, that helps me out a little bit. 4 times 1 minus 59049 over, and then 1 minus a -3. Wait a minute, minus a negative, that's the same as saying plus. So this is 1 plus 3, which would be 4. Okay, so that makes it easier. And then 1 minus 59,049. If I did that on my calculator, 1 minus 59,049, I get negative 59,048. So now let's divide it by 4. So divide that by 4. Okay, so that means that this whole number can just get replaced with, in parentheses, with negative 14,764. So this just becomes 4 times that number, negative 14,762. Multiply those two together, so times 4, and you get your answer, which is negative 59,048. Okay, so if you type that into your calculator properly, you should get that number. So, you can skip these steps if you just are really confident in typing this in. But, this is the majority of the work right here. If you show this, we're going to give you, almost all your points. And then, just type it in and you get your answer over here. Oops, sorry about that. Okay, the next one is evaluate each infinite geometric series. So it even tells us what to do there. It's an infinite sum, and the only one that we have for that is geometric. So this is the equation that we're using. S equals A1 over 1 minus R. I keep putting my R's in parentheses. I recommend doing that. Just so when you're typing it into your calculator, you don't miss a negative or anything like that, okay? All right, anyways. So again, this is the explicit rule. So the explicit rule gives us the A1, 16, and the R, 1/4. So I'm gonna plug those in there. So let's see, 16 goes on top. And then 1/4 is R, so R is 1/4. There we go. Then, you just type that in your calculator if you want. So 16 divided by, 16 divided by parentheses, because you want to put a parentheses because it's an equation in the bottom. 1 minus parentheses 1/4. And then you should get the following answer, 21.3 repeating. And, you can always turn that into a fraction if you wanted to, which is, it doesn't give you that. So 62 thirds. That's the other answer that you could get there. Oh, man. All right, so let's see here. That's it for this one, okay? And then now let's do the convergence divergence one. All right, so to tell if it converges or diverges, first off, that only happens when you have an infinite geometric sum, okay? So you need to make sure that it's geometric. And then the way that you figure it out is this. If the common ratio of the geometric sum if its absolute value, or in other words, just the number there, regardless of sign, is between 1 and 0, then that means that it converges. If the common ratio is bigger than 1, regardless of its sign, so if it's positive or negative, doesn't matter, then that means that it's going to diverge. Okay, so let's figure out what happens with each of these on number 14 and number 15. With number 14, to get from 2 to 4, 2 to 8, 8 to 32, 32 to 128, you keep multiplying by 4. So this is geometric, and the common ratio is equal to 4. So that number 4 is bigger than 1. So that means that the whole thing diverges. You don't have to write down all this stuff right here. Like, if you know the rule that if it's bigger than 1, then it diverges, you just write diverge on there, and you're good to go. Next, let's find the next common ratio. So from negative 12 to 6, 6 to negative 3, 3 to positive 3 over 2, that keeps multiplying by a negative because the sign keeps changing, and then it keeps dividing by 2, so that's like multiplying by 1/2. So my common ratio is negative 1/2. And regardless of the sign, so in other words, forget about the negative, 1/2. Is 1/2 between 1 and 0, or is it bigger than 1? It's between 0 and 1, so that means that the whole thing converges. So you just write converge or a C on it, whatever you want. All right, the next problem. The following is a survey of the number of bears found in Alaska. If this trend continued, how many bears were there in 2011? So what keeps happening to the bears? So from 5,000 to 2,500, 2,500 to 1,250, it keeps dividing by 2 each time. So this says nothing about writing out a formula or anything, so we can just continue this pattern going to 2008, 2009, 2010, and then 2011. So let's see, if I divide that by 2, 1,250 divided by 2, I get 625. So in 2008, there were 625 bears. Divide that by 2, and you get 312 and a half bears. Well, let's not count that half bear, so that means that there's going to be 312 of them. Divide that by 2, and you get 156 bears. Divide that by 2, 156 divided by 2, and you get 78 bears. All right. So 78 bears left over in 2011. That's not a lot. How many would be there in 2020 if the trend continues? Well, I mean, you can continue on with it if you want. 78 and then divide by 2 again, that'd be 2012. Divide by 2 again, that's 2013. We're down to 19 bears. Divide by 2 again, that's 2014, so we're down to 9 bears. Then 9 divided by 2, so this is 2000 and what would that be? 12, 13, 14, 2015, 2016, 2017, 2017, and then 2018. So we're already down to 0 bears, so they're dead. Extinct. Those poor bears. Save the bears, guys. Don't use that many straws, the plastic ones. Or get a metal straw or something like that. And, if you see a bear, be nice to it. All right, that's it. For the test review is over. Good luck on your test. And that's it.